All right, the next one we're going to take a look at here is the y equals x cubed minus 1. I'm going to do this on the same graph to just show you that this y equals x cubed minus 1 is the exact same graph that we had before. It's just pushed down by 1. So we see that negative 1 is the point where our graph has its inflection point. So we're going to put in 0, negative 1 here. And then we're going to just go ahead and do some plug and chug work here. So we have an x and a y, and we have 0, negative 1. And then what happens when we get 1 and negative 1? Well, when we put a 1 in, we get 1 cubed minus 1, which is 0. And so let's put that one in right there. So when we get 1, we have a 0. And then what happens when we put negative 1 in? Well, negative 1 cubed is a negative 1, and negative 1 minus negative 1 is a negative 2. So what you see here is you get a negative 2. And we'll put that one in, negative 1, negative 2. And then we're going to do our 2 and our negative 2 and see what happens with those. So when we put 2 in, 2 cubed is 8, and 8 minus 1 is 7. So we have 2 and 7, and so that one's not quite as far up as it was before, so I might be able to get that one in. And 2 and 7 there. And what happens when I put negative 2 in? So negative 2 cubed is negative 8 minus 1, which is a negative 9. And so this one goes way down here at negative 9. And so this is negative 2, negative 9. And finally, I can draw my lazy S shape through this, just like that, curving kind of around like that. And now what I see is basically this same graph, if it was drawn on a perfect coordinate system, would be just pushed down 1 unit. And that's an idea called the translation of a function. We've taken the general function y equals x cubed and we've translated it down by 1 unit. You'll learn a lot more about those when you take a trigonometry class. All right, now we're on to adding polynomials. Our next topic is adding polynomials. Now we're going to do this 2 different ways. The first method is just like we did when we were combining like terms before and simplifying algebraic expressions. We remove the grouping symbols, we group the like terms, and then we combine the like terms by adding their numeric coefficients. So in the first one here, you notice that the parentheses here around this first polynomial and this second polynomial, because its addition, really have no meaning. So we're just kind of going to ignore those, right? Just ignore those, because we can simply take a look and say, okay, well, I have 8x and I have x squared. 8 plus 1 is equal to 9, and those are x squared. And then I have x terms here and here, so I have 2 of these and 5 of those, which makes a total of 7 of those x terms. And then plus, and then finally my constants, I have a 5 and I have a 3. 5 plus 3 is 8. And you see that's just simplifying algebraic expressions, except for we've put this fancy name on it of adding polynomials. All right, in our next one, again, because we have addition all the way across, we can ignore all kinds of grouping symbols. These here, 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 and here can really just get ignored because I have all just addition. So I take a look across and I'm going to look for like terms. Now, in this particular instance, what we have is we have not polynomials but algebraic expressions, but it really doesn't matter. They're the same exact thing. So my polynomials or my algebraic expressions, I'm combining like terms. So I have 8xy squareds and an xy squared here, which makes a total of 9xy squareds. And then I look across and I see x terms. So I see an x there, I see a negative 2x there, and I see a 3x there. So 2 plus 3 is 5, and 5 plus negative 7 is a negative 5. Or nope, negative 2, sorry. Negative 2x. And then finally, I see my constant here, and so I have a plus 3. And that's my simplified term. Now the next one we'll do in the next video, and it's a subtraction one, so we're going to have to remove that grouping symbol by distributing the subtraction through.